The next speaker going from the past over the present now to the future probably needs no introduction. He has been with us many times. Professor Frank Fitzek, this is for you, and I think you can introduce yourself and start immediately because I think you have much to say.
Okay, thank you very much. I was also asked to be fast because the minister is waiting, so I try to squeeze everything in and make it as fast as possible. My name is Frank, and the title of the talk is 6G Perspective of Mobile Network Operators, Manufacturers, and Verticals. And I put in brackets, and research. So you don't have to pay me more, and this is for free. I just wanted to say maybe a words what this 6G is all about and what we have seen so far. I'm also thankful for my previous speaker. He already mentioned some of the very important features of networks that I will also underline here, and it helps me to speed up a little bit. Everything that I say is based on two big projects that we have at the university. One is our Excellence Cluster CETI, which is really dealing with robotics, humans, and the communication network that enables their interaction. And 6G Live, that is a 60 million project with, from TU Dresden and TU Munich working together on the new aspects of communication systems. Yeah? We wanted to call it future communication systems. They wanted to have a 6G. They got the 6G. So where are we right now, right? It's always important to say, people talk about 5G, some are already running for 6G. That is more the situation. We left the first 4 generation behind us. We are now in 5G, and as you already mentioned today, it's only about the logo, right? It's not a network, right? It's just the antennas and the logo is there, and it seems people are happy, right? You can make business with that. And the question is, what are we doing with 6G? So one of the things that we always addressed with 5G Lab, 6G Live, whatever, are the use cases. The most important stuff that is out there is use cases, otherwise you would not make money, right? And we have them all, like healthcare, transportation, electrical plants, agriculture, whatever you have there, construction. And I think also in 3GPP, they have aligned with that, and they also addressed what kind of network characteristics you need for these kind of use cases. So the question is, what is left for 6G then, right? So in order to just get the buzzwords out a little bit, if I'm on the conferences here in Dresden or in Rome, a lot of people claim 6G is about certain things. And then you look what will come up after we have release 15. By the way, we have release 15 non-standalone currently out there, so nobody has seen a real 5G network yet with standalone if you don't have a private network or doing in your lab. But the original parameter was really 16, right? Where we said this would be 5G. That is where everything kicks in. And when you then look at release 16 and 17, you get the new radio, ultra-low latency, edge computing, network slicing. That will come with the next releases, okay? Then there's something about site link, right? Talking with your neighbor. Broadcasting, I also find very interesting. Even the combination of broadcasting with site link will be a very powerful tool. Then tactile and multimodality communication, that what we do in CETI, is also addressed in release 18 and later on. In 19, they already have research topics like the metaverse, right? And the whole, where people say 6G is about AI. AI is not addressed here because AI is in the network since 3G, right? All, if you know, voice codecs, they were based on neural networks and learning and so on. Robotics, everything comes here. So there's not so much space for these buzzword hunting, and the question is, what do we really need? And we have the advantage not only to do research, we also talk now, due to our private or non-public 5G networks, with these kinds of mobile network operators, manufacturers, and verticals. And if you ask them, especially starting again with the verticals, what do you want, right? And everybody tells us the costs have to go down. It should go down in costs. Then we would like to be able to manage our networks, right? The thing that you heard that 2 networks are not synchronized seems to be something that is more common than known. And performance. Everybody would like to have a release 16 standard because they need to steer, or they want to steer the robots. And the robots will stand still if you have a non-standalone 5G network from time to time. Not right away, but after a certain time it will do. Network operators are also complaining about costs. They also have to pay for the energy, and they are asking what is left for us as use cases if they are the non-public networks, right? And for the manufacturers, there's the only thing we hear from there, we want more money, we want more money, we want more money. Also, what I did not address here, everything in common, they need people. They need experts to run the show, right? That's not so easy. So some people will claim that they could run their own non-public network. You can buy it, but who should operate it, okay? So that is something very interesting for the future. We have done this in a research article. If you want to look it up, we looked a little bit into the different things and what is also left for 6G. Some of you might know we do a lot of stuff in post-channel theory, quantum and molecular communication, something that might be interesting in the future, but I will leave it out today. So if people now ask, Frank, what is this 6G? I cannot say it, right? Nobody can say it because there will be a release topic for it. For now, to make peace for myself and to justify the 70 million we have there, I just say 5G is about machine-to-machine addressing the cyber-physical systems, and 6G is about humans and machines, right? So the human in the loop that we already addressed in the excellence cluster, I can live with that. But I have one question for you. Why do we need a new standard at all? My daughter does not even have phone calls anymore. What she needs is IP connectivity. We don't need global mobility anymore. If you look at the fabrics and the robotics, they cannot walk that far, so nomadic mobility is totally fine. Level 2 of mobility is something we like. But maybe we also don't want a global standard. We want a standard that is respecting our ethical reasoning. Right? So that would be an interesting thing, how we will continue. And I think broadcast and voice calls are the only thing why we need a global standard. Everything else, we could benefit from not having a global standard. So now I'm adding a little bit the 6G perspective of research. So what is left in use cases? This one. If you look what kind of challenges we had from pandemic, skill shortage, aging society, climate change, geopolitical challenges, this is something we have to address. But it's not something that we only address in 6G. It has to do with communication networks. I will show this later. And in order to do that, for example, if you want to do something for climate change, let the people not travel so much. Let them interact over the metaverse so they will not travel. Question is how much you will spend for the metaverse itself. How much energy will be consumed over there. And it's not only then a question of the network. The network is super important. But it's about peripherals, it's about the metaverse, it's about robotics. We have to get a larger system understanding to get things done. So one of the things I would just want to mention here is, and we heard it before, latency, right? And how low you can go in 6G. 1 millisecond, lower than 1 millisecond. But there are other things that will put something on the latency bill, which are the peripherals, which is computing. Computing, apparently, is our biggest problem currently. Also peripherals, because they were never tuned for latency if it would not be for the gamers. The gamers know that, and they do something. So in CETI, I brought you something here. It's about how can we not only reduce the latency, how do we create negative latency? So the good news is, as I said, humans are in the loop, and humans are predictable. I'm sorry to say that. We have made here a nice demo that will show you something here that is very easy. You have a setup where you have a glove, a data glove, and here the student is just grabbing some stuff, and you see it was an espresso cup, right? And then you can take something else. So the plate over here, he also recognized this, and he will do now a glass, and the glass is on a certain sensor, and a light sensor, and then you see the value from the glass is around 684 milliseconds negative latency. That means before he touched the glass, we got half a second to do something. Half a second means you can go with speed of light around the globe, right? So predicting humans is something very important. That's not an engineering discipline. That's not even computer science. This is pure psychology. And then you see, for example, for this very simple setup, there are 4 different things. You can see how much latency you can gain. It's not prediction. Prediction is something different. It will not give you this. It's about learning, right? And here is the question, where does the learning happen? Does it happen in the glove? Does it happen in the network? And it will be a hybrid thing. So what we think in research right now are these 3 pillars: sovereignty, trustworthy, and sustainability. Sovereignty, that's the most important thing, and we all learned the lesson the hard way. We need our own chips. Can we please understand this? And can we create everything here? The best would be in Dresden, not Magdeburg or whatever. Let's do it here. Yeah? And when we have the chips, we need the software. So I told you something that we did on the Hannover Messe. There was a 5G Opera project that we have. There are French people, Germans, Belgium, and they just put together what they have, right, in storage. So we were responsible for the core, others made the open air interface and the antennas, and suddenly we have our own 5G network out of the box. And this is what we think we have to do not only in software, we also need this in hardware. And as I said before, it's not only 6G, it's about all communication networks. It has to do with the ICT ecosystem as well, right? So if we think about communication, if you're a student from the 90s, 80s, or whatever, you think about communication as transporting bits from A to B. But currently, computing is taking place in our ICT. And computing is the main driver for the digital transfer, where you need omnipresent computing. Or AI needs massive computing. Or what you also see is the virtual worlds. You need fast computing because people want to interact there, right? And ICT, of course, distributed computing. Whatever kind of use case you have, computing is the #1 driver for that. So the problem with computing is we have to compute, we have to transport, we have to store more and more data. This is the actual expectation from a lot of people like Cisco and Apple, what we have. And if you know how the data goes up, then you have to know this guy on the bottom. His name is Landauer. And he tells you there's a physical limit for operating on a bit. So you need 3 times 10 to the minus 21 joules to operate on a bit. And this is in a very noisy environment. So this is the blue line, right? So if you just multiply the minimum bit you have with the data we are producing, that is the blue line. If you do it with the current system, the green ones, then you will end up in around 2035, where we will eat up the whole energy production on the globe just to deal with our data that we are producing. Not with the current data that we produced. If you want to store or compute it, you're going way up, okay? So we have to find a way to deal with this. The other thing is, another guy that you should know, Shannon. He not only gave you the Shannon limit, he also said we have to sit on the digital platform because we can beat noise, right? Coding is very good and very powerful against noise. But this is the burning platform for us. So we have to understand what else we can do. And last but not least, this guy, Turing. He wrote a paper in 1936 about the computability numbers. So not everything is computable. And we are living in an analog world, and we have a digital platform to compute. That's the reason why these cars will never walk alone or autonomously in the city. You need a fucking network to do that. They never understand that. It's not computable. So if this is a problem, what can we do, right? And I told you already, we are digital natives, right? But maybe we should go back to analog. We come from analog. Our world is analog. Why don't we do everything in analog? I told you the reason. Shannon said it. It's the transport that makes it. Quantum is another platform that we can use. Everybody talks about quantum computing. But this is very energy power hungry, right? So, and there's biology. There are 4 different platforms, and you can do all of that, like computing, transport, storage on these things. Just to highlight some, right? Currently, we do computing in the digital world. You can do it analog. Analog is faster and low energy. It cannot do everything, but there's something more. It's more precise. We know this from information theory if we work in a very strategic way on finite fields to overcome the problem. But now, with the analog metaverse and everything you want to have, you don't want to have a digital twin. You need an analog twin. Quantum computing is clear, but very energy hungry. Storage, everything is stored on a hard disk. Why don't we store on DNA? Mother Nature is storing on DNA. Good news, you store it once, no energy to keep the one, and 10,000 years later, you can dig it out of the ground, it's still there, right? Transport, right? We are in the digital way, and we have quantum. Quantum is more the quantum entanglement, enhanced communication. There are a lot of good options. And I think what we have to do is we have to rethink all of these platforms and to see where is the advantage. And here in Dresden, we have also already companies that are thinking about analog computing, building chips for this. Very good for us. And we are using them to come up with our coding strategies or with our metaverse. We are trying it out. And this is maybe this is the last one, because I have to be speeding up a little bit. One of the most important stuff is that we create here on site our own startups dealing with these problems, right? And in 6G Live and CETI, we have here a number of startups we are engaging with. They are doing something in the terms of sensors, human-machine interfaces, robotics, communication, or cloud computing. In this very moment where we are standing here, there's one new company signed, which is called Ecologic Computing, that will deal with these platform questions. Not all of them will be successful, but what they do is they attract the talents to Dresden, and even if they're not successful, they will just redistribute in new startups or in the successful ones. So that is one of the things we have to do. So don't think always about data rate, right? There are other things that we have to think about in these days, and think about the 3 bullets. Thank you very much.